Hi, Assalamualaikum everyone. I am Ahmad Amin Ayman bin Ahmad Tajuddin, and I will teach you how to solve optimization question.
Hang on, I'm coming, Osa.
Of June 2019 question 2c under optimization. Firstly, we will read the stimulus press. Figure 1 below shows a piece of wire of length 200 cm is bent into the shape of a triangle ABF and a rectangle CDEF as shown. Given that BC equals to DA, this is our figure 1. ABF is a triangle and CDEF is a rectangle. We are given three sub-questions here. Firstly, we need to express x in terms of y. Secondly, we need to show that the area A centimeter square enclosed by the wire is A equals to 378 y minus 12 y square. Lastly, we need to find the maximum area enclosed. Our first question is we need to express x in terms of y. So before we continue to answer the question, we will abstract out all the information given. So this is our figure and this is our information that we get from the stimulus. Length, or as we are also given perimeter, equals to 200 centimeter. BC equals to DA and DE equals to CF, that is 3y. DE 3y, CF 3y. And CDEF is a rectangle, so that means CD is also equal to EF, that is x plus 8. Then we can go through to answer the question. So our perimeter is 200 centimeter. And to find perimeter, we need to add all of the sides from this figure. We have AB, BC, CD, DE, EF, and lastly FA. And we need to equate it with 200. For AB, we have 7 centimeter. For BC, we have 3y centimeter. For CD, we have x plus x centimeter. DE, we have 3y centimeter. EF, we have x plus 8 centimeter. And lastly, FA, we have x centimeter. And it is equal to 200. From this equation, we can simplify it one by one. Firstly, we simplify 7 with 8 and 8. 8 plus 8, we get 16. 16 plus 7, we get 23. And then we can simplify 3y and 3y. We get 6y. And lastly, we can simplify x plus x plus x. We get 3x. And it is equal to 200. So we need to express x in terms of y. So another terms that not containing x, we will move it to the right hand side. So we get 3x equals to 200 minus 23 minus 6y. 200 subtract with 23, we get 177 minus 6y. To find the value of x that we need, we can divide 3x with 3. We divide 177 with 3. And we divide 6 with 3. And then we get x equal to 59 minus 2y. And we denote this as equation 1. The second question asking us about to show that the area A centimeter square enclosed by the wire is A equals to 378y minus 12y square. From the first question, we get x equals to 59 minus 2y, and we denote it as equation 1. So this question involving area, so we need to find area of triangle and rectangle, and after we find the area of triangle and rectangle, we need to add them. So from this figure, area of triangle, we can define it by half we multiply with base. So base for the triangle is x, and length for this triangle is 3y plus 3y, and that's why we get 6y. So we can simplify this. 6 over 2 we get 3, and x multiplied with y we get xy. Rectangle. So for rectangle, we will multiply x plus x with 3y because all the side is the same. Then we just expand this. We get 3y multiply with x, we get 3xy. We multiply 3y with 8, we get 24y. We can simplify 3xy here. We just add them and we get 6xy plus 24y, and we get the equation 2. From this equation, there is a variable x here, so we can substitute equation 1 into equation 2 by replacing x with 59 minus 2y. So here we have replaced the x with 59 minus 2y, and we get 354y minus 12y squared plus 24y. We can simplify 354y plus 24, and then we get 378y minus 12y squared. Our answer is equal to the question. So that means we are done solving this question. The third question, we need to find the maximum area enclosed. From 2 Roman, we got A equals to 378y minus 12y squared. Firstly, we need to differentiate A with respect to y. So when we differentiate A with respect to y, we get dA over dy. When we differentiate 378y, we get 378. We just keep the minus sign. We bring the power 2 to the front. We keep the constant. We just copy in the bracket, and then we deduct 1 from the original power. And then we can solve this. We get 378 minus 24y. Because we multiply 2 with 12, we get 24. Step 2. When dA over dy equals to 0, what is the value of y? So our dA over dy is 378 minus 24, and we need to equate it with 0. So from this equation, we can solve for y. So we just move the term negative 24 to the left hand side, and then we get 24y equals to 378, and then we just need y in the left hand side, so we will divide 378 with 24, and then we get the value of 15.75. Step 3, we will find d2a over dy2. That means we differentiate again dA over dy using the second derivative. Our dA over dy, it is equal to 378 minus 24y. When we differentiate again dA over dy using the second derivative, we get d2a over dy2. When we differentiate 378, we get 0 because we are differentiate a constant. we just keep the minus sign here, and then when we differentiate 24y, we get 24. 0 subtract with 24, we get negative 24. I want to remind that we get a negative value here. That means we will get a set graph. Our set graph will give us a maximum point. Therefore, we can say that 15.75 will maximize the area. From A equals to 378y minus 12y squared, we can replace y with the value of 15.75. We substitute variable y with 15.75 and then we solve the equation. We get the answer as 2976.75. I think that's all from me. Thank you.